Hello everyone, welcome to my channel Dr. Tapati's presentation. In this video, I am going to do a comparative study of competitive, uncompetitive and non-competitive reversible enzyme inhibition. A competitive inhibitor bears a structural resemblance to a particular substrate and thus competes with that substrate for binding at the active site of an enzyme. An inhibitor binds at the substrate binding site in case of competitive inhibition. Therefore, EI complex is formed. Whereas in case of uncompetitive inhibition, the inhibitor binds directly to the ES complex and ESI complex is formed with the binding of inhibitor with ES complex. In this case, uncompetitive inhibitor is not binding with the free enzyme, only binding with the ES complex. In case of non-competitive inhibition, the inhibitor reversibly binds with both free enzyme as well as with enzyme substrate complex at site different from the active site. Hence, two inactive complexes are formed. Those are EI and ESI. In case of competitive inhibition, the inhibitor does not act on enzyme but does prevent the substrate from approaching the active site. In case of uncompetitive inhibition, the inhibitor affects the catalytic function of enzyme but not its substrate binding site. Whereas in case of non-competitive inhibition, inhibitors often deform the enzyme so that these do not form the ES complex at its normal rate, and once formed, the ES complex does not decompose to normal rate to yield products. So in case of non-competitive inhibition, structure of active site is changed. In case of competitive inhibition, an inhibitor competes with substrate for binding to the active site of an enzyme. Therefore, increasing substrate concentration prevents binding of the inhibitor. So, inhibition can be reversed after increasing the substrate concentration. But in case of uncompetitive inhibition, inhibitor exerts its effect only at high substrate concentration at which there is lots of ES complex. Therefore, increasing substrate concentration does not prevent binding of the inhibitor. In case of non-competitive inhibition, the degree of inhibition is not reversed by increasing the substrate concentration. Therefore, only in case of competitive inhibition, inhibition process can be reversed if substrate concentration is increased a lot. The general reaction model of competitive inhibition is this, where you can see that inhibitor is binding with only free enzyme, not with ES. In case of uncompetitive inhibition, inhibitor is binding with ES complex. In case of non-competitive inhibition, inhibitor is binding with free enzyme as well as it is binding with ES complex. In case of competitive inhibition, EI complex is formed. In case of uncompetitive inhibition, ESI complex is formed. In case of non-competitive inhibition, both EI as well as ESI complexes are formed. In case of competitive inhibition, Michaelis-Menten equation is V0 is equal to Vmax into substrate concentration divided by alpha Km plus substrate concentration, where alpha is equal to 1 plus inhibitor concentration divided by Ki. In case of uncompetitive inhibition, Michaelis-Menten equation is V0 is equal to Vmax divided by alpha prime into substrate concentration divided by Km by alpha prime plus substrate concentration, where alpha prime is equal to 1 plus inhibitor concentration divided by K prime I. In case of non-competitive inhibition, Michaelis-Menten equation is V0 is equal to Vmax by alpha into substrate concentration divided by Km plus substrate concentration, where alpha is equal to 1 plus inhibitor concentration divided by Ki. In this case, Ki value is equal to K prime I. Ki value is equal to K prime I. When substrate concentration is very high, at that time V0 is Vmax in case of competitive inhibition, whereas in case of uncompetitive inhibition, at that time V0 value is Vmax divided by alpha prime, and in case of non-competitive inhibition, V0 is Vmax by alpha prime. At very high substrate concentration. That means when substrate concentration is about infinite value. In case of competitive inhibition, Lineweaver equation is 1 by V0 is equal to alpha Km divided by Vmax into 1 by substrate concentration plus 1 by Vmax. In case of uncompetitive inhibition, Lineweaver equation is 1 by V0 is equal to Km by Vmax into 1 by substrate concentration plus alpha prime divided by Vmax. Whereas in case of non-competitive inhibition, Lineweaver equation is 1 by V0 is equal to alpha Km divided by Vmax into 1 by substrate concentration plus alpha by Vmax. Now, if you see competitive inhibition process, in this equation, you can compare that alpha part is added in the slope where as compared to normal enzymatic reaction where alpha part is omitted. In that case, in case of normal enzymatic reaction, that means in absence of enzymatic reaction, Lineweaver equation is 1 by V0 is equal to Km by Vmax into 1 by substrate concentration plus 1 by Vmax. So alpha part is not present in that case, whereas in case of competitive inhibition, alpha is added here. Alpha is multiplied with the slope. In case of uncompetitive inhibition, alpha prime is present at the y-intercept value. And in case of non-competitive inhibition, alpha is present in the slope part as well as in the y-axis intercept value. Now, if you compare Km and Vmax values, you can see that in case of competitive inhibition, Vmax remains unchanged, Km value is increased. In case of uncompetitive inhibition, Vmax is decreased as well as Km value is decreased. In case of non-competitive inhibition, Vmax decreased but Km remains unchanged. Now, if you plot 1 by V0 versus 1 by substrate concentration, that is Lineweaver plot, you can see that the diagnostic for competitive inhibition is the double reciprocal plots with different concentrations of inhibitor intersect at 1 by V0 axis at 1 by Vmax value. Whereas in case of uncompetitive inhibition, a series of Lineweaver plots at various inhibitor concentrations consist of a family of parallel lines, and in this case Vmax and Km both are different, both values are decreased. In case of non-competitive inhibition, diagnostic graph is for different values of inhibitor concentration, a family of lines that intersect to a left of the 1 by V0 axis on 1 by S axis at minus 1 by Km value. So in case of competitive inhibition, all the lines are intersecting on 1 by V0 axis at 1 by Vmax. In case of uncompetitive inhibition, parallel lines are found, and in case of non-competitive inhibition, all the lines are intersecting on 1 by S axis at minus 1 by K. Slope of the competitive inhibition is alpha Km by Vmax, and slope of uncompetitive inhibition is Km by Vmax. It is obtained from the Lineweaver equation. And in case of non-competitive inhibition, slope is alpha Km by Vmax, which is present in the Lineweaver equation of non-competitive inhibition. Let's see few examples of competitive, uncompetitive and non-competitive reactions. Malonate, glutarate and oxalate have the structural similarity with succinate. Therefore, they are the competitive inhibitor of succinate dehydrogenase. If you see this reaction, you can see the substrate is succinate and enzyme is succinate dehydrogenase, and this enzyme is converting succinate to fumarate. In presence of malonate, the reaction is inhibited. And another example is sulfanilamide, which has the structural similarity with the substrate para-aminobenzoic acid or PABA. This is the substrate of dihydropteroate synthetase. This is the enzyme and inhibitor is sulfanilamide, and which has the similarity with PABA. Therefore, sulfanilamide is the competitive inhibitor of dihydropteroid synthetase. And rare example of uncompetitive reaction is rare. In case of one substrate reaction, it is very common in bi-substrate reaction. Hydrazine is the uncompetitive inhibitor of aryl sulfatase. Phenylalanine is uncompetitive inhibitor of alkaline phosphatase. Valproic acid is uncompetitive inhibitor of UDP glucuronosyl transferases, and camptothecin, which is used for the cancer treatment. This is the uncompetitive inhibitor of topoisomerase 1. Non-competitive inhibition example, metal ion requiring enzymes can be inhibited by chelating agents like EDTA. So EDTA is non-competitive inhibitor of metal ion requiring enzymes. Etoposide, which is used for the cancer treatment, this is also a non-competitive inhibitor of topoisomerase 2. And tacrine is the non-competitive inhibitor of acetylcholine esterase. This inhibitor tacrine is used for the treatment of Alzheimer's disease. Thank you very much for watching this video. In order to motivate me, kindly like, share and subscribe this channel. Don't forget to press the bell icon to get notifications.